Today we're going to begin by looking at linear functions from an algebraic, numerical, graphical, verbal perspective and extract information relevant to model this function. Let's begin by talking about what a function is. A function is a special relationship where each input has a single output. It's often written as f of x equal to something. X's are used to show the inputs and f of x's are used to show the outputs. Anytime we see an f of x, it is the same thing as seeing a y value. Functions can be represented in various forms. They can be written as ordered pairs, in tables, as an algebraic formula using symbols, or in a graphical form such that you would see on an XY plane. We're going to begin by looking at a practical example of weather data. We're taking a look at a southern US city during the year 2020 and the average monthly high temperatures for that city. We can take this information and we can write it into an XY chart. We're going to let January be represented by a number 1, February by 2, March 3, and so forth. So our X values are our months and our temperatures are our Y's. Again, Y's are the same thing as f of x's. So when we talk about the word inputs and outputs, inputs are any values that are X values. In our case, our inputs or our X values are months. These would be the numbers 1, 2, 3, and so forth. Our outputs would be our temperatures. Again, Y is the same thing as our f of x values. And these would begin at 47, 52, and so forth. Let's take a look at how we can use our graphing calculator to plot this set of data points. You'll see a snapshot on your screen here, but I'll also guide you in the process. I've used a TI-84CE calculator. Go ahead, grab your calculator. In order to enter data points, you'll want to go into the Stat menu. Stat is located just to the left of your left arrow key. Press Stat, Edit, and you should see a table appear. The L1 values are the X values. Again, X represents months. So we would type in 1, 2, 3, and so on. Our L2 values represent our Y or our f of x values. We'll jump back and forth just a minute to enter these. Again, these values are coming from the table that we had above question number 1. So hopefully your calculator looks something like this. Now, in order to look at these points being plotted, if we take a look at our calculator and press graph, we'll notice that we don't see anything here. there's a couple of additional steps that we have to take. First, we have to turn on our scatter plot. So you'll want to press the second button and Y equals. Select option number 1, and you'll want to highlight the word on by pressing enter. This will change so that the word on is flashing and there is a black box highlighted around it. Even if we press graph again, you'll notice that we still do not see any of these points plotted. The reason for this is our calculator starts off with a -10 to 10 viewing window. If you press window on your calculator, you'll see the X-min and X-max -10 to 10 and the Y-min and Y-max 10 to 10. Your calculator features may have become a little mixed along the journey. So if it doesn't look like this -10 to 10, you can always hit zoom and 6 for standard. That takes you to this -10 by 10 viewing window. Again, though, our goal is to plot the points that we have. And so we will have to adjust our window to fix those points. Recall back in our entries here for the table, our X values are between 1 and go up to 12. The L2 values are generally in the 40 to maybe up to 90 range. So on the calculator, one option is you can press zoom and go down to option 9 for stat. Once you do this, your graphing calculator will automatically fit your window based on the data that you entered into the scatter plot or the stat edit feature. So how should we adjust the viewing window to see the data? 1, we want to turn on the scatter plot window. We'll do this by pressing second, Y equals, which is our stat plot. Highlighting on. And we will also adjust our window settings. And our window settings were by pressing zoom and option 9. Let's continue. So we were able to see our data points plotted, and this makes sense. The temperature during the year here in North America goes up and then comes back down. We're now going to move into some of the questions that we will find when working with linear functions. One question that we're often asked is to find the slope between 2 points. So here we're looking at January with 47 degrees and April with 71, and we're asked to determine the slope between these two. Our slope formula can be found by looking at the change of Y values. Change is represented by this triangle, it's red delta, over the change in X values. Sometimes we see this in algebra class as y2 minus y1 over x2 minus x1. We can label our points x1, y1, and x2, y2. Substituting these into the formula, we would have 71 subtract 47 over 4 subtract 1. Feel free to grab your graphing calculator to help you with some of the arithmetic as we go. To go back to a regular viewing window, you'll press second, quit, and here's where you can type in any calculations. So 71 minus 47, we can put in 24, 4 minus 1 is 3, and dividing this gives us 8. If you decide to do this all at one time with your graphing calculator, do make sure that you put the top part of the fraction in parentheses and the bottom part of the fraction in parentheses when calculating. This will ensure that your order of operations is correct. So the slope between these 2 points is 8. What would this mean? This means that on average, the temperature would rise by 8 degrees each month between January and April. Recall these temperatures, we scroll back up to the top, were average monthly high temperatures. So the average monthly high temperature increases by 8 degrees each month between January and April. What does average rate of change mean? Well, average rate of change is the same thing as slope. The average rate of change is 8 degrees. It is the amount that something is changing per X value. Using the same points as in question 4, write an equation to describe the line that passes through these points. So notice we have just 2 points here. If we wanted to draw a line through these 2 points or come up with an equation, then oftentimes we will use what is called point slope formula. We'll use this often in calculus. Point slope formula is usually referred to as y minus y1 equals m times x minus x1. We've already found the slope above, that is our 8. We will also want to use one of the points with it. Now you can use either point, but for consistency, I will stay with the point 1, 47. I'll write this out to the side. This was our x1 and our y1. So we would write y minus 47 equals 8 times x minus 1 and simplify. Depending on the textbook that you're using, they may have you simplify this in more detail than others. I'll try to show all of the steps the first time. So here's our equation. This is in y equals mx plus b form. We also, though, want to make sure that we can write our equations in function form. So if you'll notice, it says, write the equation in the function form using t as the name of the function output and x as the function input. What this means is that we will keep the x's where they are, but anywhere that we see a y, we're going to use it in function notation. So we would write t of x equals 8x plus 39. For any x month that you would plug in, you could find the corresponding t of x or y value. Now, this equation is not going to work for every point on our graph. Recall, our points go up and they come back down. So this line really just represents a function in between January's point and April's point. Let's enter this equation onto our calculator. To type in an equation on our calculator, we'll press the y equals button, and then we will type in the equation that we just found, 8x plus 39. The X button is located to the right of your alpha key, or the green button on your calculator. You can go ahead and press graph. And now we can see we found the line that goes through just January's point and April's point. Again, the equation that we entered was under the y1 on our calculator. We put in 8x plus 39. The y1 was the same thing as the y that we used here, and also the same thing as this t of x. Again, they're just different notations depending on where we're writing them. Using the function that we determined in question 4, what would t of 3 mean? So if you recall, we wrote in function notation t of x equals 8x plus 39. If we were asked to find t of 3, then this means that we are going to plug in a 3 for our x. So we'd have 8 times 3 plus 39. Simplifying 8 times 3 and adding our 39 would equal to 63. What does this mean? Well, it means that in the third month being March, we would expect the temperature to be 63. If they asked us to find t of 10, we'd repeat the same steps, only plugging in 10 for our x. What would this mean? Well, this would mean, based on the equation, that in October, we would expect the temperature to be 119. Does this seem right, though? Would this function be a good representation for our entire data set? And the answer to that is no. It works well for the early values, for the months between January and April. But it doesn't work so well after that time. We'll move on to our next tile and see what other types of functions might be useful.